Polynomials. You have already studied algebraic expressions, their addition, subtraction, multiplication, and division. You also have studied how to factorize some algebraic expressions. In this video, we shall start our study with a particular type of algebraic expression called polynomial and the terminology related to it. Thanks for watching this video. Don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. A monomial in one variable is the product of a constant and a variable raised to the non-negative integer power. A monomial is of the form a times x to the power of k, where a is a real number and k is a non-negative integer. In other words, a monomial is a constant times a variable raised a non-negative integer. Let's see some examples. Minus 3 times x to the power of 4 is a monomial. Minus 3 times x raised to the power of minus 2 is not a monomial, since the exponent of the variable x is not a non-negative integer. 5 times x to the power of 1/3 is not a monomial, since the exponent of the variable x is not a whole number. Now let's see what a polynomial is. A polynomial in one variable is an algebraic expression of the form the monomials that make up the polynomial are called the terms of the polynomial. Look at the example. The numbers that multiply the variables are called the coefficients. Pay attention. If there is no number multiplied on the variable portion of a term, then the coefficient of that term is 1. The exponent on the variable portion of a term tells us the degree of that term. The degree of the polynomial is the highest power of x in the expression, that is, the value of n. The example is a polynomial of degree 5. Polynomials are usually written in descending order according to degree. The leading term is the first term when the terms are written in descending powers of x. The leading coefficient is the coefficient of the leading term. The constant term is the term containing no variable. If a power of x is missing, it is because its coefficient is 0. We can rewrite the polynomial as follows. Evaluating a polynomial is the same as evaluating any algebraic expression. Replace each x in the expression with the given value and perform the calculations. Look at the example. Take the polynomial, replace each x with minus 2 and perform the calculations. Pay attention. We now replace each x with 0 and perform the calculations. Polynomials are added and subtracted by combining like terms. That is, combining terms with the same variables raised to the same powers. Let's see now how to add and subtract the polynomials. Pay attention. First, we shall find the sum of the polynomials. The idea here is to group the like terms and then combine them. Remove parentheses and identify the like terms. Group the like terms together. Use the reverse distributive property, factor. If there is no number multiplied on the variable portion of a term, then the coefficient of that term is 1. Add the numerical portion of each term, being careful of the signs. We will now find the difference of two polynomials. Change the signs of the terms being subtracted. In this case, be sure to change the sign of each term in the second polynomial and follow the rules for adding like terms. To find the product of polynomials, we need to use the distributive property repeatedly in the product rule for exponents. Notice the product rule for exponents. When the bases are the same, add the exponents. Let's see how it works. Let's multiply two polynomials. Multiply each term in the first polynomial by each term in the second polynomial. Pay attention. Be careful of the signs. And always remember to add like terms. Let's see another example. Distribute each term of the first polynomial to every term of the second polynomial. Be careful of the signs and always remember to add like terms.